Hello class. On this video we're going to be learning about carbon fibers and bioplastic. The definition for a carbon fiber that we're going to be using is the one stated in the Encyclopedia of Materials, Science and Technology back in 2001, which states that carbon fibers are a few microns thick, lightweight, very strong, and stiff black synthetic fibers with long aromatic molecular chains comprising mainly of carbon. So there's some definitions that we have to go over. We're going to unpack this. So microns, what is a micron? It's a unit which is a 1/1,000,000th of a meter. So this is what a micron is. So we start the definition with stating the length of the carbon fiber, followed by a description of the weight, which is lightweight. And since it's lightweight, that means that it has a low density. So you can start filling out your handout with this information. And then we're going to be focusing on the aromatic molecular chains. We're going to look at the sequence of reactions and how those carbon fibers are formed. So the first stage of the reaction is that we start off with this polyacrylonitrile, which is we're gonna call it PAN, so PAN. So this PAN contains 68% of carbon and is currently the most widely used precursor for carbon fibers. So precursor, that means that it's like the starting material to create something else. So for example, glucose is the precursor of cellulose and starch. So the precursor for the carbon fibers and most carbon fibers is this PAN molecule. So in the first stage, you're going to apply heat. And this heat, it's 300 degrees Celsius, so 300. So you need to write that down in your handout. So after you apply 300 degrees Celsius of heat, then you form this cyclic ring structure. So you have here in your pan, you have, I'm pointing out here, you have this cyano groups, which are the carbon nitrogen triple bond. And as you can see here, after you apply 300 degrees Celsius of heat, you're left with the ring structure and you get rid of this triple bond. And now you have a double bond and then another single bond between nitrogen and carbon. Now, let's go to the second stage. So you're going to keep applying heat. This time you're going to apply 700 degrees Celsius. And then what happens here? So the ring structure, right, that you have here and after the first stage, you're going to be forming aromatic pyridine groups, which are right here. Okay, so what happens here? As you can notice here, you're losing hydrogen atoms and you're forming this double bond. You see here you have single bonds. You lose the hydrogens and then you form double bonds. Oh, and because you're losing hydrogen, that gets released as hydrogen gas. Okay, so that's one of your byproducts. So now on the third stage, okay, you had this pyridine structure, aromatic structure, and then you're applying even more heat, this time between 400 to 600 degrees Celsius. So you're going to be combining some of the adjacent chains, so the chains that are next to them, they're going to be combining together, as you can see right here. And then of course you're getting rid of more hydrogens in the form of hydrogen gas. So you're ending up forming like this kind of ribbon, okay, and you're expelling hydrogen gas. So you're just combining chains together for the third stage. So now to create even more ribbons, like this is a ribbon right here, now we're going to be combining two ribbons. For example, you need to apply even more heat, this time between 600 to 200 degrees Celsius. So you see how the chain is getting way bigger. The ribbons are getting way bigger. Okay? And again, in this time, because you're combining these two nitrogen structures, you're losing the nitrogens in the form of nitrogen gas. So you see how you're getting rid of these nitrogens right here to like kind of sandwich this whole structure. So you get rid of them and you're releasing nitrogen gas because you're getting rid of the nitrogens right here. And this is the fourth stage. So just make sure that you understand what happens on each of the stages and know the sequence of each of the stages. Now, carbon fibers have been used in many fields. Some of them are aerospace, industrial, sporting goods, and also medicine. That's the fourth one that's not here. This is a table from this article right here, published by Huang. I don't know how to pronounce this. Huang X 2009. So what I want you to notice is the pattern here that is over time, the demand and the consumption of carbon fibers has been increasing on each one of the fields that we have here. You notice how the numbers are increasing. This is just a general idea that I want you to get from this table. So now we're going to move on to bioplastics. The definition that we're going to be using for a bioplastic is the one stated by Bergman et al. In 2018. So this is a recent definition which you have in your handout. So you can read it in your own time. For the types of bioplastics, these are the ones that I want you to know. Let's just get a general sense of each one of them. Of course, by now, cellulose, starch, and protein should be familiar to you because you know that they're what? Biomolecules. Now, the polylactic acid and the poly-3-hydroxybutyrate, these two, 4 and 5, these two are polyesters. So if I say poly, which means many, and then esters, well, you know what an ester is, right? By now. The difference is that the polylactic is a transparent plastic and is produced from corn. And this poly-3-hydroxybutyrate is produced by a certain bacteria that processes glucose from cornstarch. Now, protein-based plastics. I hope you remember when we work with casein. Remember the lab from milk that you were trying to make a glue? So casein is used to make plastic. So that's a fun fact. You can also use soy protein to make plastic. Those are just some examples. Now, for starch, this is the one that is the most widely used. Okay, and the reason for that, there are 3 reasons why starch is the most widely used. Reason number 1 is that it's cheap, okay, barato. The second reason is because it's renewable. And the third reason is because it's very abundant. And for cellulose, well, you just have to remember what cellulose is made of and know that you have a chain of cellulose esters forming the bioplastics. And then, well, this concludes the topic of the day. And then I just have a very quick announcement that you do have a quiz on Friday. It's going to be most likely on Socrative. I'm going to be writing a quiz that's going to be based on the topics of polymers, carbon fibers, and bioplastics. Okay, so thank you so much for watching. I hope you have a good week.